Hi. Now in this video, we're going to talk about two different measures of correlation. These are also called correlation coefficients. The two coefficients that we're going to talk about are two very popular measures of correlation. They're the Pearson coefficient and the Spearman's coefficient. We're going to look at a few examples of how to calculate these coefficients. We're going to talk about how they're different from each other. And we're also in this video going to talk about how to interpret their values. Our next video is about correlation coefficients. And when we talk about correlation coefficients, we're actually talking about two major types of correlation coefficients. And they're called the Pearson, that's an N, and a Spearman. The Pearson coefficient and the Spearman coefficient. So over the course of this video, we're going to talk a little bit about what these two coefficients are, how they differ from each other, what kind of information they convey, and of course, how to calculate them. So with that, let's go right in. So the first coefficient that we're going to talk about is called the Pearson correlation coefficient. And the way we obtain that is quite simple. We divide the covariance value by the standard deviation of both variables involved. Let's revisit covariance a little bit and write down what the formula is for covariance of two variables. So as you might remember, it is xi minus mu x multiplied by yi minus mu y, the whole divided by n minus 1. And of course, this is sigma over I, summation over I. We know what each of these individual terms mean. Mu x is the mean of all variables in x, of x. Mu y is the mean of all variables in y, so mean of y. And the reason we use n minus 1 instead of just n, as we discussed earlier, is just so that we can get an unbiased estimate of covariance. So we take this covariance value and we divide that by the standard deviation of x and the standard deviation of y. And that will give us our Pearson correlation coefficient. So the next one is the Spearman coefficient. How exactly is that different? So for the Spearman correlation coefficient, we're not going to use x and y directly, but instead we're going to take the rank of x and the rank of y and find the covariance of that quantity. And then we're going to divide that by the standard deviation of the rank of x and the standard deviation of the rank of y. So over here, what do we even mean by rank? Rank is basically the ordered ranking of all data points in the variable x or the variable y. So for example, over here, we have a set of 5 values of x, 10, 15, 9, 12, and 5, right? And in order to find the rank, what we're going to have to do is basically rank them in descending order, which is simple enough. And when we do that, we find that 15 gets rank 1, 12 gets rank 2, 10 gets rank 3, 9 gets rank 4, and 5 gets rank 5. So that is a quantity that we're going to use when we calculate the Spearman coefficient. We're going to find the covariance of this rank value for x and y, and we are going to find the standard deviation of the rank for x and the standard deviation of the rank for y. Right off the bat, this gives us some pretty big differences, right, between the two of them. So we'll illustrate that in a little bit. But at a high level, the Pearson coefficient captures the strength of the linear dependence between two variables, and the Spearman coefficient captures how they're related monotonically. That is basically, does quantity y increase as quantity x increases, or does quantity y decrease as x decreases, and so on.